Now we've got our data in batches, but it could be a little bit hard to understand what's going on in a batch. So let's build a little function which is going to explore what's in our batch so we can visualize what's happening. Because if we have this little output here, we know deep down that these are actually images and these are labels. It would be good to see them. So let's make a little heading here, visualizing data batches. Command MM to turn it into Markdown. And let's give ourselves a little bit of communication. Our data is now in batches. However, these can be a little hard to understand / comprehend. Let's visualize them. Because I'm not sure about you, but I like to see things in action. So to do that, we'll import our trusty matplotlib. Look at that, auto suggestion. And then we'll go create a function for viewing images in a data batch or a data batch data. We Australians, the Australian accent, like to throw R's onto the end of vowels wherever they are. We might do it, just show 25 images, because if we're doing too many, like we have 10,000 plus, so we might just show 25 at a time. And we want images and labels, because what we're going to do is basically plot an image and then above it put the label. And nice and simple, we'll go displays a plot of 25 images and their labels from a data batch. Wonderful. All right, so let's set up the figure. We'll go plt.figure. We'll make it fig size. Now I've had a little bit of experience with setting up this plot size, so hopefully 10 by 10 is good enough. If not, we can change that. Then we'll go loop through 25 for displaying 25 images. So we'll just set up a simple loop. We'll go for I in range 25. Then what can we do? Well, we need to create a subplot. Let's make it 5 rows, 5 columns, because that's 25. And then we'll have to display an image on each of the subplots and then add a title to each of the images. Well, that shouldn't be too hard. So create subplots. We'll go 5 rows, 5 columns. Go ax equals plt dot subplot 5 I plus 1. So this is, it's because we haven't imported matplotlib yet. That's why the docstring isn't showing up. There we go. Parameters. Where do we got? It got rows.column. So this is number of rows, this is columns, and this is index. That's all you need to know. Display an image. Some of the matplotlib docstrings can be a bit annoying, like when they go args, keyword args, and it just inherits off some other class and you can't really find it. If you need to check out what this actually does, check out the matplotlib full-blown documentation. We want to plot the ith image. So because we're looping through, this is going to be a data bunch of images and labels. So we want to show the ith image. So the ith index. Am I saying that right? The ith image. Add the image label as the title. So we'll go plt.title and then unique breeds, because that's our list. Remember, if it still lives in memory, it should. Unique breeds is our list of unique dog names. Get the unique breeds label. We want to index that where labels, the ith label is the maximum value. So in other words, if we go y0 argmax 19, this is just exactly what we're going to be doing with that line up there. Unique breeds. So this line here is the title of our plot. Boom. See what I mean by defunctionizing functions to really explore what's going on? So if you want to figure something out, remember, always you can just pull the function apart. Rewrite the code for yourself, because that's how you're going to understand something. Turn the grid lines off. Actually, we might see it with them on before, so we know exactly what this is doing. plt.axis. That's a nice simple function. Show 25 images. What do we need to do now? So because our data is in a batch, we need to essentially unbatch it to visualize it. So we can do that by going train images. Let's see the code first, then we'll see what's actually happening. Train labels equals next. So what next is it returns the next item from an iterator. Oh, well, thank you, docstring, for that. Because train data is in the format of a batch, so if we go train data, we need to turn it into an iterator. There we go. So we can do that by calling the method as numpy iterator. And what's this going to say? Returns an iterator which converts all elements of the data set to numpy. So basically what this is going to do is turn... Oh, there we go. We got some information here. Those doc strings are a little bit hard to read there for me. But let's just go through here. What's it going to do? So it's going to take our batch data set. It's going to unwind it from a batch and turn it into a numpy iterator. And then thanks to next, it's going to grab the first batch off the top of this, out of this iterator. And then because it's split it, it's unbatched it, training images, so this one here, this shape here, is going to be the first thing that gets returned. And train labels is going to be the next thing that gets returned. So don't take my word for it. If in doubt, run the code. Now the reason this might take a little while to run is because if you remember, when we batchified our data set up here, we've got this map function, getImageLabel, which is going to process our images. So that's why when we're working with batches now, because whenever we run it, it's going to process our images in the background. So there we go. So instead of dealing with file names now, we're actually dealing with processed images, so a little bit more data. This is a massive array, right? Because we've got train images. This should be, let's see how long it is. Can you guess how long if it's in a batch, if it's a single item in a batch? And how long is train labels? Should have really run that in the next cell so it didn't have to batchify our data. 32. There we go. So this is where next comes in. So we've taken our train data, unbatched it using as numpy iterator, or turned it into an iterator. We've taken the next, so the one off the top, so essentially just taken the batch off the top, and returned the images and the labels. Whatever batch you're working with, we're working with images, so this is why this is train images. If you're working with some other type of data, this would be that other type of data, and this would probably still be your labels. But they are of length 32 because our batch size is 32. So now let's use our code, our visualization function. Now let's visualize the data in a training batch. What did we call it? Show 25 images. Show 25 images. Train images. Train labels. Wonderful. So this is the data we're working with. This is our training data. Notice how they're all squares because we've resized them 224 and 224. And this is why I wanted to plot the axis off, because we want to get rid of that junk around the side. So let's do that because we're trying to display images here. Let's plot it again. Awesome. This is our training batch. Now if we come up here, let's do the same for visualizing a validation batch. If we run this again, Oh, actually, I want to show you something that's going to highlight the difference. If we copy this down here, we can remove that as well. This is what I was looking for. Every time we run this, so take note of this one here, Saluki, Tibetan Terrier. Just remember these 5 images here. Now let's try run this again. We see how the top row is different, and you'd notice the rest would actually be different as well. Now, why do you think that is? It's because if we come up here, when we create a training batch, every time we call the training batch, it's going to shuffle the data. So if we were to go do this again, while that's running, we'll write out one for the validation set. Now let's visualize our validation set. So we'll go val images, val labels equals next, val data dot as numpy iterator. Wonderful. And then we'll go show 25 images, and we'll go val images, val labels. So we'll run that, and we notice that we've got some different ones here. Hey, look at that. That dude's holding that puppy. I could do this all day. Just look at that thing. How cute is that puppy? So we'll run this one more time. Take note of this one. Remember this guy holding his dog here. Remember this one that looks kind of like a shower curtain. So we'll run that training. And notice this for validation as well. So remember this dog in the bathtub and this one under the chair. We see the train images have changed, because if we go back up, when we created our data batch, we shuffled the training images every time we create a batch. And for our validation, this one in the bathtub's still here, because we come up to where we created our validation batch. We don't shuffle the validation data. Now, keep thinking about why that might be important. We'll get to that in a moment. I know I've said that a few times now, but just want to have you think about it for the time being. And so, now that we've visualized, we've created data batches, and now we've visualized them to make a bit more sense in our head, I think the only next step is to see what we can do about building and training a model. Let's get on to that in the next video.